Hello, I am Taylor Brown, and we're currently working on exercise 1 for lab 1, where we just have a 10 kilo ohm resistor in series with a diode, and then we're supplying a VN to that circuit. And we're going to be sweeping a VN from negative 10 volts to positive 10 volts, and we're going to be measuring the current across the diode for each of those voltages. So we've already gone through and taken a look at what happens to the current when the voltage is negative, and it gave us a voltage of about negative 0.01 microamps, just because we're limited by the hardware that we're using. But here the polarity of the clips are switched, and we're supplying technically positive 10 volts from our DC power supply, but our prongs are switched, so it's negative 10 volts. And here, through our multimeter, we're getting a reading of negative 0.01, as I stated before. So now we're going to start going into the positive VNs and see what happens. Alright, now we're at the point where we have looked at the current through the diode for our positive voltages, and we can see that it kind of moves just linearly upwards as the voltage supplied to the circuit increases. But we noticed that when the voltage was anything above 0, it gave us a very small reading, and then starting at above or about 0.7 volts, it gave us a more linear reading of it moving upwards. And this matches with what we simulated here, where whenever the voltage supplied in becomes above 0, it kind of moves exponentially upwards, and then after about 0.7, it's a linear pattern. So these are our final values.
My name is Brendan Black. In exercise 2, we are tasked with creating a circuit with a safe resistor, and so we calculate the minimum resistance using a voltage source of 12 volts. And then using the data sheet from online, we find that the max voltage forward of the diode and the max amperage are 1.1 volts and 1 amp respectively. So using this calculation with a 10 times 10 safety factor, we should get a resistance of 110 ohms. In this circuit, we have a 100 ohm resistor and a 10 ohm resistor in parallel to create that voltage, or to create that resistance. And so we will then measure the voltage and currents. Okay, and for exercise 2, we are tasked with using the same circuit, but applying a step voltage of 0 to 9. We currently have it off, but we pause the simulation here to show that the voltage of the diode in the blue drops as a time delay going from one value to the other. And so, using two cursors, we find that that time is 31 microseconds.
This is Carter Hurst. There's my student ID and name. Here's my multisim, 12 volts, 1K potentiometer. We have the multimeter measuring, the sim multimeter measuring it in 0%, which means there's no resistance, which would have the LED at the highest light. Here's what that looks like in real life. 12 volts, 10.134 volts over the, starting from the top of the resistor to behind the LED. Same right here. We're moving it to 50 now.
This is always, this is turn on. Just turn on.
The light visibly lessened. It is now at 10.2. Here it's at 10.2. Now it's at 100%.
Checking that, and it's within 10K. Let me look.
Lessened more. 10.222.
8K.
This is at 10.232.
This is 10K.
This is Thomas Young, student ID number 1135-71-59-1, doing Lab 1, Part 4 for E-Lab. You can see I have my Zener diode set up here for collecting the Zener voltage. I am now turning on the 10 volt signal. and I'm receiving about 4.74 voltage with some drain there. And now I'm just going to set this up real quick to take current with that off.
And for exercise E, the measured current at 0% on the potentiometer, full bright.
I am using 220 ohm resistance because I calculated the safe value for 25 milliamps to be 219,
Alright.
or 212, which is right there.
But he said that 50%.
I need the resistance.
So this set to take amps now, and
Just needs the voltage at.
the fuse set in so nothing blows.
Maybe just so we just need to
Turn this on and receive about 24 milliamps.
for each LED.
Set up for measuring current. That's it. And this is exercise 4, part 2, using the 100 ohm resistor. You can see right now I'm measuring the voltage across the Zener diode and the 100 ohm load resistor, which is giving me 3.124 volts with a 10 volt input. And then I will measure the resistance or voltage across here. Which gives us a 6.91 volts. And so I can use those voltages and resistances in order to calculate the actual current flowing through, instead of measuring current in a parallel circuit there. Meaning that this will give me everything I need to calculate my final value.